Hi everyone, today's solving a question called Palindrome partitioning. So, given a string, we want to partition string such that every substring on this partition is a palindrome. And by the way, the palindrome string is a string that reads the same from backward and from forward. Okay, so let's look at the example to help understand. So in this example, a string is equal to AB, right? So one way to break into a single A, and single B because both single A and single B are palindrome string. And the other way is to break this into a double A and a single B, because this double A is palindrome and this single B will also be a palindrome. Okay, now check the intuition of the problem. Next thing to think about how to solve this problem. So let me just join here using string equal to AB example. So our intention to traverse the entire string to add letters and to check its palindrome. So let's draw a string equal to AB here. Okay. And if you watch my previous video, you know of, okay, for this backtracking strategy, we need a path and we need the result, right? So here we initialize path empty array, and also the result ends empty array. We now finish the initialization. The next thing to set the current point, right? So you see the beginning letter is A, right? So it's the current point at this A. And next thing you want to check is the string have already visited. So let's say it's visit string. And the string we have not visited, right? So the remaining string. And here the visitor string is A, so write A here. And the remaining string should be B, right? So write B here. Okay, the next thing to check is this visit string palindrome. Of course, this single A is a palindrome, right? So I want to append this A to our path. Append A here. And the next thing, you want to keep checking this remaining string, right? So remaining string is B. We're on the same approach as we did in this string equal to AB. So get the new visit string as B, and then the new remaining string as an empty string, right? And at this step, we want to keep checking. Okay, is this new visit string palindrome? Of course, this single B is palindrome, right? So again, I want to append this B to the path. And then I want to keep check this remaining string. But here, the remaining string is empty. So I think no need to check. We just return now to break out this branch for A. Okay, now finish the branch for A. Is the next thing to do the same thing for B, right? So let's use a different color and send the current pointer now at B. Okay, for B again, we need the visit string and the remaining string. So a visit string here can only be B. And the remaining string is empty because there's no letter to right side of B. Okay, sorry, here should be AB because we have already visited A before visited B. Okay, now I want to check is this visit string palindrome. This is not palindrome, right? Because if we read from forward, it will be AB, but if we read from backward, it will be BA. So this is not palindrome. Therefore, there's no need to check this remaining string, and we return none to break this entire approach. Okay, now finishes that, the only thing we want to do is to append the path to result, right? So you found, okay, the length of path equal to length of the original string, we just append the path to string. So the final result for this solution is AB. So we return this result and we are done. Okay, now finish the graphical explanation. The next thing to write the code. So first, let me write the general framework for this backtracking solution. Initialize empty result array and the path array. And then we'll call the helper function, which I will write later. So we pass in this string, in this path, this is the result, and return the result in the main function is done. Okay. Now next thing to think about how to write the helper function, right? So let me rename this helper function to backtrack and divide the backtracking here, passing all these variables. Okay. So first thing we'll do backtrack is to append pass to result if the condition satisfied, right? So if found, okay, we have reached the end for this string. We want to pen our pass to result. Sorry, here should be a string parameter. And otherwise, want to run recursion to check the red string. So for I in range length of string, the first thing to set the VT string, which is s all the way from beginning to I minus 1. And the remaining string, which is x all the way from I plus 1 all the way to the end. And then want to call the help function to help out with the recursion, right? So we call the help function, pass into the remaining string, the first variable, and then the pass should be added by the weighted string, and the result should be same. But this condition had precondition, right? So only if the weighted string is palindrome, we want to check recursively for the remaining string. So let's say it's palindrome function, which we are later, and pass its weighted string. Okay. Now we should the backtrack function. The final thing to write out this is palindrome function, right? So this function will have a single variable, a string, and you found string from forward, which is that, and string from backward, which is this kind of expression in Python. If this one equals this, it means these two strings are this string the palindrome, right? And otherwise this string is not palindrome. Okay, now we should code the next thing to submit the code to see it works. Okay, you see the time capacity and memory usage of this solution is not bad, right? If you find this video helpful, please subscribe to my channel. See you next time. Thank you.